channel. Today we will take a topic from physics, electrostatic, and learn about the concept and equation related to it. First, fractional electricity. When two bodies are rubbed against each other, one of them loses some electrons which are absorbed by the other. Second, the magnitude of charge on electrons E equal 1.6 into 10 raised to the power minus 19 coulomb. Third, conductor are material that readily conduct charge. Fourth, insulator are material that does not readily allow electric charge to move. Fifth, additivity of electric charge. The total charge of a system is the algebraic sum of all individual charges distributed over the system. If the system consists of n charge, namely Q1, Q2 and so on up to Qn, the total charge of the system will be Q total equal Q1 plus Q2 plus dash 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 plus Qn. Now 6. Conservation of electric charge. The total charge of an isolated system is conserved during any process. Charge can neither be created nor be destroyed. It is simply manifested as a positive, negative or neutral. 7th, quantization of electric charge. The charge always exists as an integral multiple of certain minimum charge E. Symbolically, it can be written as Q equal NE, where Q is the charge, E is the charge, Q is the total charge, E is the charge on electron, and N is the number of electron. 8th, Coulomb's law. The magnitude of the electric force exerted by one point charge on other point charge is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. The force is directed along the line joining the two charges. It is attractive if the charges have unlike sign and repulsive if the charges have like sign. For vacuum and in SI system, F equal 1 upon 4 pi epsilon naught magnitude of Q1 into magnitude of Q2 whole divided by square of R, where the value of 1 upon 4 pi epsilon naught equal 9 into 10 raised to the power 9 Newton meter per coulomb, Newton meter square per coulomb square, where epsilon 0 is permittivity of free space. The value of epsilon naught equal 8.85 into 10 raised to the power minus 12 coulomb square per Newton per meter square. The SI unit of charge is called coulomb. 10th, the force exerted on charge Q2 due to charge Q1 is equal in magnitude but opposite in direction to the force exerted on charge Q1 due to charge Q2. Symbolically, it can be written as vector quantity F12 equal vector quantity F21 negative, where F12 equal 1 upon 4 pi epsilon naught Q1 Q2 upon R21 square into unit vector R21. In other words, equal 1 upon 4 pi epsilon naught Q1 into Q2 upon magnitude of R1 minus R2 magnitude of R1 minus R2 whole cube into R1 minus R2, where R1 and R2 is the position vector of the charges Q1, Q2 with respect to origin. 11. In a medium other than vacuum or air, Fm means force exerted by any charge on any other charge. It means Fm equal 1 upon 4 pi epsilon naught epsilon r into q1 q2 upon r square into unit vector r, where epsilon r equal fm upon f0 equal epsilon upon epsilon naught. Fm means force on a medium and f0 means force on air or vacuum. That is called electric constant. Number 12. Superposition principle. For an assembly of charges, the total force on a particular charge is the vector sum of the individual Coulomb's force exerted on it by all other charges. The force between any two charges being unaffected by the presence of other charges. Number 13. For a system of n charges q1, q2, qn, the total force F1 on the charges q1 due to all other charges q2, q3, qn is F vector F1 equal vector F12 plus vector F13 plus vector F1n. For a continuous charge distribution, the electric force F at a point can be calculated from F equal integration of df, where df equal 1 upon 4 pi epsilon naught q into dq upon r square unit vector r, where r is the unit vector in the direction from charge element q1, charge element q plus dq, and r is the distance between them. Electric field. Electric intensity capital E at a point is defined as the electric force F experienced by a unit positive test charge Q0 placed at that point. Symbolically, electric field intensity E equal limit Q naught tends to 0 F divided by Q naught Newton per Coulomb. 16. Electric field due to a point charge Q at a point distance r is given by field intensity E equal 1 upon 4 pi epsilon naught into Q upon r square unit vector r. 17. The force exerted on a charge Q placed at a point where the electric field is E is given by force F equal Q into capital E, where E is the intensity of electric field. The derivative of the formula will be given.